actually the person who probably suggested that we should have this.
Good.
So you wanted to tap on this, that's why you suggested.
So I feel that we should also look at real examples of other successful companies. How do they do things? And there's a lot to learn from the real practical examples. Because obviously theory is one thing, and when we apply those things to practice, we get different solutions. So I have chosen Slack here, and the main reason that I work for an enterprise software company. We build software for enterprises. And the reason why we like Slack, or why I have chosen Slack for this talk, is that the approval rate of Slack as a business software are really high. So if you are a Slack user, you are very happy with the software and you pay for that as well. So just to get some sense of how many of you know Slack or have used Slack. Okay, yeah, so half of so we'll probably start with the very basics, what Slack is and what are the reasons Slack is more popular. So this is the basic screen of Slack. So if you have not used it, I'll just go through it once. So in some ways, it is a persistent messaging system. So you can message, communicate with your teammates, and all those messages you communicate are persisted as well. And the way they do that is they create all these channels, which are more like topic-specific forums. And the one innovation here is that you subscribe to these channels rather than somebody adding to you to a particular channel. So it's more like voluntarily that you say that I'm interested in this topic and you subscribe. So there are some say private channels as well, but generally the culture is more towards openness, so that everyone should get all the information, and you may be observing that information, but you are getting that information, and if possible you would be able to contribute. So these are all the channels, forums, topic specific. Another thing you see here is that you also get some sense of who is online at that point of time. You directly can message that person in your team. And so if you click on a channel, you see something like this. So if you post a link, it unfurls that link to you as well. So if you post a link, you will get some idea of what that link is as well. So pretty much that. And so some of the things we have not shown here is, so obviously very small features which delight user are something like loading screen. So if you go to any enterprise software, there will be something saying just loading. Something specific about Slack, when you see loading bar, you can customize a quotation which that comes, which kind of delights users. So I've seen organization put up their mission statements or something very motivating, so that every time you log into that screen, you don't even realize that the page is taking a lot of time to load, and you are busy understanding the code and probably internalizing it. And another very small feature which I feel is different in case of Slack is warnings or error messages are very much specific. So general enterprise software would throw an exception that there is some problem in authentication, but Slack gives you an error that there has been a problem in signing you in, so which is more understandable for a general person. And Slack is one of the softwares which started with enterprises, and a lot of people in their own life have accepted it. So I know a lot of meetups which have some of the Slack channel, Slack messages, and informal groups as well, running clubs are on Slack as well, just to communicate and share information. So this is pretty much basic of what Slack is. Approvals are very high, people have to pay. So after a level, if you cross, so per user, per month, there is an amount to be fees which is pretty high. So since people pay that, so I was more interested in why people pay. So there is a UX part of it, and then there is a very interesting story about the architecture part of things and how the company came into existence and everything. So I thought I'll put up a case study and we'll discuss it. Yeah, so only disclaimer is that I don't work for Slack. So. Yeah, so I'll be covering these topics in my talk. One is how in general Slack works. and the real-time messaging part of it, and some nuances of their architecture, and some of the problems they are facing with their current existing architecture and how they plan to solve it. Just to give you an idea that they have around 4 million daily active users and around 5.8 million weekly active users. And so at the peak time, these are the numbers they have reported that 2.5 billion are say connected. So the way it is that you will log into your Slack account and you keep it open so that you will be getting notifications and much like any chat application. So in that way, you may not be reading all the time, but you will keep the session open. So in that way, you will be connected for a longer duration, but you will be looking at the messages for a smaller duration. These are the numbers they have provided for active users, but they may vary. And half of their users are outside US. And some of the themes which I could say get out of their architecture was that they are little conservative in terms of architecture. So they use technologies which are not very new. So they rely on a lot of old technologies, much like MySQL for their database side of things to storing, and so that is something which will come across their architecture. Another thing is that they are open to write code, so they have a lot of code for their message server. So they do not use something like Kafka to pass their messages. And the other thing is they also believe in minimalism that somehow goes with the conservative nature as well. That if they have to introduce a new technology which they are not using in their current setup, they discuss it really hard why that particular use case cannot be solved by the existing technology. So there have been a lot of blog posts why they don't use Cassandra and still go with mice. So this is very simplistic architecture of Slack. So they have two main components. So one is the web application part of it, another is message server. So message server is something real-time message flows through, and web application is to get application started and to persist those messages. So we'll discuss this in detail. So this is how you will get started. So first you hit get URL of Slack, then you post a request to get started, and you ask for the first string, which is rtm.start. So RTM in their terminology is real-time messaging, and then you provide your authentication tokens and things like that. So once you make this call, you hit to a PHP code. So their code in some sense is a sharded lamp stack. So we discussed this in detail. For PHP part of it, they have been on a hip hop virtual machine, and so that they can use some gradual typing features of headline. So when that they ask for first start RTM start field, they go to the servers. So web application is, as I told you, MySQL, sharded MySQL. And that sharded MySQL is team specific. So when you register at Slack, it will ask you for a team to which you want to get registered. And a particular team stays in a MySQL shard. Just to get that information where the shard is, you go through these main servers, so which are replicated MySQL servers. So this is one level of indirection which they have added so that they can easily move around the shard of a team depending upon, since team can grow larger than a shard, so they will become a part. So they generally move into a better infrastructure. So just to maintain that level of flexibility to redirect and move a team from one infrastructure to another. So they have these main server in between, which gives the exact location of a shard. And this, so once you get that information where team is located, then you hit a particular shard, and that provides you with the information. So all things you can basically think of stay in MySQL. So team information, user information, channel information, all forums, all messages, all comments, even emojis, stay in MySQL. And they have replicated shards which are across two data centers, quite apart from each other. And they are, as I told you, are sharded by team. Okay, so why MySQL in their case? So the rationale they give is that this is some technology which has been there for a really long time, so they have faith in that. And they also like the relational discipline which comes with MySQL. And another very interesting point I would like to point at this point of time, that if you know the history of Slack, so Slack was earlier a game company, and we'll probably come to those points how this architecture is still that of a multiplayer online game. And they have experience and tooling for that. Interestingly, they do not actually use asset property of MySQL, because they have something like, as I said, sharded MySQL. They use it in master-master replication mode, and both are write enabled. So the possibility is, for a particular shard, they obviously divide it based on teams. A particular team can be writing to one pair of shard, and another team can be writing to another pair of shard. So that is, they try to give you best effort service. But in cases where a particular shard is down, obviously multiple teams will be writing to the shard. So the idea is that a team information will stay on the shard, but if obviously if team is not really large, there will be multiple teams staying on a particular shard. And in some cases where there is master-master replication, obviously there can be lags. And in extreme cases, say one server is down, or say theoretically or in practice as well, it is possible that two person writing at the same time also may write two different shards. And for one shard, order is A, B, and for another shard, order is B, A. So these kind of inconsistent come in the system, but they have some automatic way of resolving basic ones. But when they themselves are upgrading systems, and there are cases where they have to manually resolve these inconsistencies. And they have another system where after say 3 months, they will obviously get into something which is a little inconsistent. So they regularly run some mechanisms to make these two master servers consistent as well. But why this works in their case most of the time is, if you are a particular team, you will be reading mostly from the shard where you wrote, most of the cases. So, which works in their case very fine. Even if you see inconsistency of order in which you have written, most of the cases that is fine. And the reason they give is that they assume that the input always be given by human, and the order at which inputs are coming would be limited by itself. So obviously they do not expect, say, a stream of data coming from IoT and writing to their message box. So this is something which is they have, which is a restriction, but they have assumed that this is not the use case they want to solve, and that's why their write system, right, master replication system works well for them. And another thing is why they want this to be master, because they want writes to happen all the time. So even if your one shard is down, they want write not to get waste and happen. So once you go through this cycle, you get a first loading screen, which is RTM start. So if I can compare it with the gaming site, so this is the first frame you will get, which will give you the some ways the state of the system at that point of time. How many players are on, what is their position on the screen, and so in that way, if you compare it that, so they give you all the information in the channels and the presence of all the people in the team. So that is to them, so you can relate to them as players online and what is the state of the game at that point of time. So they actually talk in that terms of technology as well. So at this point of time, you will get that state, and then you also will get this WebSocket URL. So once this initial connection is made, all further messages will be passed on WebSocket, which will be alive as long as you are connected to the site. So this first frame gives you the image of whole team, and as I said, this is a snapshot of the whole team, and updates actually trickle down through WebSockets once connection is established. So just to revisit what we have discussed, that first you will try to connect a web app, you will get the state, and after this your connection to message server is established, and then further messages will actually be passed by message server. So coming to message server part now, so once the connection is established, message server acts as your write amplifier and helps in persisting your messages. So message server is Java code which I have written, and so much like a game application, it was earlier kind of used to gives you change in the user position and the actions of different users. So that was earlier propagating those kind of messages, and they kept it that way. And so they keep this WebSocket connection alive. So another thing that can possibly happen is, so if there is a message, open a connection, send that message, and then that message be broadcasted to all the other clients. But they say that they want better performance, and for them delay is something which they don't want. So they keep this WebSocket connection all the time to all the clients. So if you send a message that goes to message server on that WebSocket, and then that is broadcasted to all the other clients in your team, and to people in that channel, to wherever it is needed. Another thing is that you need to process that message as well. So there is a site called to web application which saves that message. So this looks a little simple. There are some complicated cases here as well, because say suppose you got a connection to message server, but there will be some lag when you get the state and when you connect to message server. So just to take care of that, if you saw clearly, when it returns a WebSocket connection, it also returns a hash, which is kind of a cursor in event log, so that tells you exactly what state you are getting. So message server is also aware of the state by that hash, and then gives you all the events which has happened after that point. So as soon as you connect to a message server. Another thing which they can run into is that obviously there is a site call to persist all those messages. If for some reason that connection is not available or they are not able to persist that message, they have a queue. So they will put that message in a queue. If they are not persist at that point of time, they will be able to try to persist it at a later point of time. And another thing is, the most of the messages, it's not only about the messages you send. Most number of messages are some sense of presence message. So since you see all the other teammates online, there has to be some way to broadcast to all the other teammates that these all persons are online. So those are also some messages go behind the scenes. So there is another component in their architecture which talks about different work. So something like link unfurling, which we saw, that you paste a link, after some time you will get a there will be a call to that link and it will try to get you a snapshot of the page and will show in the message itself. So they obviously these are kind of tasks which can be done asynchronously. So they put those kind of tasks on a Redis queue. So basically there are multiple queues based on priority. So based on priority, those will be picked up by workers and will be serviced. So they do that for something like link unfurling, search indexing, and export import, which take a lot of time and should be ideally done asynchronously. So this is the final. To sum it up, you connect to web application from mains, get to shard, get message, get my RTM start back, send message, and which will be broadcasted. So think of these, if you just do a link unfurling, you are basically checking that everything is working, that your message is able to broadcast, and you are able to communicate to web app that there is some task to be done, and then your job queue picks that task and services it in response to back to message server, and then that is again broadcasted to all the clients. And there are a lot of other things which are missing, as you can see. So I've basically talked about the main message survey part of it. So all the DBs are wrapped around Memcache. So these caches are not team specific, but so they themselves figure out what all queries are asked more, and based on that they push those queries to Memcache. There is another service for machine learning models, and they also do some kind of rate limiting. So obviously the system is like that. Another thing is messaging service or server is also team specific. So your particular team is supposed to hit a particular message server, but if nodes are high, say message server can break, mains can break, for that matter shards. So there is particular MySQL machine for particular team that can break. So they do some kind of rate limiting. They know what kind of rate each of these components can handle. And if the rate is approaching that level of critical load, they start shedding load. They will start showing you warning that we cannot service this. And then there is search feature. So the search is primarily covered by Sharma. So these are some of the good parts in the architecture, that they have partitioned by team, and the way they use it in their favor is obviously if you are a larger customer and you pay them more, they will put you on a hardware and system which is better, so you will not see performance issues. Since this is paid product, they say that this works in their favor, that if you pay more, they will put you on a better hardware. And similarly with message server, like they say there's low latency of broadcast. So some of the problems in their architecture that they openly accept at this point of time, some of them are mains failing. If you see mains as single point of failure at this point of time, and if you have a large team, obviously the first frame they send to every user would be really large, because that has to get all the information. And mass reconnect is another thing, that since the infrastructure is team partition, so mass reconnect is the case where suppose your internet was down and suddenly internet is up now, everyone in the team will get connected at the same point of time, and the load will be on same infrastructure because they are partitioned by team. So same shard will be hit and same message server will be hit at the same time. So what they are planning to do about everything. So we will talk about some of the solutions which they are working on and they have in mind. So one thing is, so I'll first elaborate about the problems here. Since they have two master paired, but if one fails, obviously there is more load on another. So if the failure is because of load, obviously another can never handle it. Large RT in start, the first string descent. So they have done some heuristics. It say that the first string is order of n square users. So as users increase, it increases n square in size. And obviously, mass reconnect is some way connected to the large RT start frame. Like if everyone connects at the same time, so if there are more users, obviously this is a problem. So currently they are having some large users of order of 10,000. So large team at this point in time, which Slack is handling is over 10,000. But obviously these were some of the issues we faced and we are facing in some ways. So coming to the solution part, so there has been some prototyping in terms of replacing means with a data storage which is more scale out in nature, but that is not very serious at this point of time because of two reasons. Because they say that they have researched very highly into how to protect their mains at this point of time, so they have memcache around their mains. So even if mains fail, so for some time they will most of the users will be serviced by the cache itself. And obviously they limit the rate at each point, so they limit the rate at mains as well. So this is not one of the priorities at the point of time, but obviously going forward they are planning to do something like this if things will work out. And obviously change would always be very difficult to move from one type of database to another type of database for a thing which is already a single point of failure. Yeah, so these are some of the statistics they publish. I'm not very sure how true they are because I tried and I couldn't get. So I, on my machine in India, take around 4 seconds to get the first string. And that is because if you see in the architecture that my request goes to US, and even if we in India are there, every time I message that has to go to US and then it will broadcast it to the person sitting next to me. This is how the architecture is. So for some geographies like India, it takes a lot of time. But this is something that they publish in the blog, so I have put it here. But the other thing they are planning to do is to lazily load some of the data in the channel. So if there is new notifications, it will be loaded. You will get it in the first frame. Otherwise, you won't get any information in the first frame about any of the channels in which there is no update for you. So they try to be lazy in that part. For mass reconnects, they are trying something like a project called Final, which is application level as edge cache model. So just to explain what this is, that they want to put a cache for each key which contains the state of the system at that point of time. So if you see, yeah, so this is the architecture pre-panel. So what it will happen if you put two caches. So one thing to note is, for a single key, they will put multiple caches. So this is one way of scaling on cache without changing any of the infrastructure. So it will be easier for multiple clients to get service from different caches. And they're trying to solve the problem of mass reconnects. So currently it is only operational for their internal team. Yeah, so I've been showing till now only the cartoon architecture diagram. So this is something which they follow and which is available publicly on Amazon website. So they obviously use Amazon Web Services, and if you can see whatever we have talked about is there in some form or the other. So yeah, so it's basically thank you.